The introduction of the 50,000-ton Giga Press marks a revolutionary shift in automotive manufacturing, enabling Tesla to produce the Model 2 at an unprecedented price and scale. This machine is far larger and more capable than anything the industry has previously seen, designed not merely to eliminate parts, but to fundamentally redefine how an entire vehicle is produced. The story of the Model 2's affordability begins with understanding the Giga Press. This next-generation system evolved from Tesla's initial 5,000-ton die casting machine, developed by Auto Group, which delivered about 55,000 to 61,000 kilonewtons, or 5,600 to 6,200 tons of clamping force. That early machine proved the concept of casting large, single-piece vehicle structures. The new 50,000-ton giant, weighing around 410 to 430 tons, is designed to create even larger monolithic structures, such as the entire underbody floor or lower chassis, in one solid piece. This process removes countless welds, eliminates multiple assembly steps, and significantly simplifies the entire build process. With a fast cycle time of approximately 80 to 90 seconds, the machine can output 40 to 45 castings per hour, approaching 1,000 parts per day. This high productivity is crucial for rapidly scaling manufacturing, cutting costs, and making the Model 2 affordable while maintaining high quality. The Giga Press represents a complete shift by replacing complex multi-piece construction with stronger, simpler single-piece aluminum castings, leading to fewer components, lower cost, and a more durable frame for the Model 2. Tesla's need for a machine as massive as 50,000 tons reflects its continuous push to the limits of high-pressure die casting. The 6,000-ton generation was initially used for Model Y's rear underbody, consolidating over 70 components into a single casting, which reduced welding cut inspection time and increased torsional rigidity. This marked the first shift from an assembled to a monolithic cast vehicle. The 9,000-ton version followed for the Cybertruck's larger, thicker structural sections, using higher clamping force for a more stable mold seal and improved geometric accuracy, critical for supporting the Cybertruck's rigid steel exterior. The 50,000-ton Giga Press, with a clamping force of about 61,000 kilonewtons, is 8.3 times larger than the 6,000-ton version and is the most powerful equipment in the die casting industry. This immense pressure ensures that the multi-plate steel mold, spanning tens of square meters from Model 2's full underbody, remains perfectly sealed throughout the cycle. This allows for the single-shot casting of the entire Model 2 and Cybercab underbody, including hollow channels, load-bearing ribs, and battery module mounting points. Crucially, the massive clamping force guarantees metal uniformity by ensuring all regions of the mold experience even pressure, allowing molten aluminum to spread uniformly without creating weak separation lines, thus producing a fully unified structure that smaller systems cannot match. To withstand the forces required to form a full vehicle underbody, the 50,000-ton Giga Press is an industrial powerhouse, enclosed within a reinforced steel body about 20 meters long, 7 meters wide, and 7 meters high, with a total mass of approximately 420 tons. This structure houses the critical systems: the melting chamber, the holding furnace, and the multi-mold casting assemblies. The melting chamber, designed to tolerate temperatures near $850 processes aluminum combined with proprietary alloy developed with SpaceX, holding about 500 kilograms of molten material. The adjacent holding furnace maintains nearly 600 liters of aluminum within a narrow thermal window of $750 to $850 protected by a nitrogen atmosphere, with argon and silicon carbide systems purifying the metal. The machine's heart is the mold assembly, which operates with 7 molds simultaneously. Each mold is about 3.5 m wide, 4 m long, and 1.2 m deep, designed to endure the extreme force from high-speed injection pistons that push molten aluminum up to 10 meters per second. Precise timing and pressure control are vital for the metal to fill every channel without trapping air or cooling prematurely. A built-in vacuum network extracts air before injection, reducing porosity and increasing final structural strength. The casting is finished with an ultra-rapid cooling cycle that drops the frame's temperature from around $400 to about $50 in mere seconds. AI-enhanced X-ray, thermal, and pressure sensors continuously evaluate quality throughout the cycle, giving Tesla fast, highly efficient, and consistent manufacturing platform essential for the Model 2's high-scale production. The Giga Press solidifies liquid aluminum into a full structural frame in seconds through a highly controlled, rapid process. The cycle begins with perfectly refined aluminum, around 80 kilograms for each mold, stored in the 600-liter holding furnace at ideal temperature and viscosity. Stability is critical. Too hot, and it traps gas; too cool, and it solidifies early. Before injection, the mold surface is coated with a thin-release agent for a smooth flow, and a vacuum system pulls out all air pockets. This is especially important for the Model 2's monolithic underbody with its intricate channels. A high-speed piston then injects the molten aluminum at nearly 10 meters per second, driving the alloy into the mold with pressures reaching about 61,000 kilonewtons. The precise control of the pressure curve and timing ensures the aluminum reaches every contour defect-free. Combined with the vacuum and coating, dimensional variation is kept below 0.1 millimeters. The aluminum solidifies almost instantly, with a rapid cooling system dropping the temperature from $400 $/C$ to $50 in seconds. Robotic arms remove the casting, and AI-enhanced sensors provide real-time quality verification via thermal behavior, internal pressure, and X-ray signatures. This closed-loop system creates a unified structure with drastically fewer joints and weak points, lowering porosity below 0.5% while increasing stiffness and load-bearing strength, enabling a complete Model 2 frame section to be produced in an incredibly short time. The 50,000-ton Giga Press is the key technology enabling the Model 2's price and scale by creating a major leap in automotive manufacturing compared to traditional stamping. Stamping requires dozens of steps for a conventional underbody, 300-plus steel components, 3,000 to 4,000 welds, which accumulates errors, increases costs, and extends chassis manufacturing time to 20 to 30 hours per frame, also leading to noise and vibration. Giga Casting eliminates these issues. It cut the Model Y's rear underbody from 70 parts to 1, reducing cost by up to 40% and weight by 10%. With the 50,000-ton generation, Tesla cast the entire Model 2 underbody in a single shot, an unprecedented achievement. Dimensional deviation drops to 0.1 to 0.2 millimeters, about 5 times smaller than in traditional welded frames. This shift from casting large sections to a complete underbody structure is considered the most significant advancement since Henry Ford's assembly line. The Giga Press redefines vehicle production by dramatically cutting part count, minimizing error, increasing structural durability, 20 to 30% higher torsional rigidity, and enabling affordable mass production. Production capability increases dramatically. A Giga casting line requires fewer than 100 robots, compared to 300 to 500 for a traditional stamping and welding line.